Hello and welcome. Today's lesson is going to be about lateral and surface areas. Sorry, I made a mistake here. Of prisms and cylinders. Before anything, let's go through some vocabulary words here. Polyhedron is a solid that is bounded by polygons called faces. So these are polyhedrons because all the faces, all the sides are polygons. Okay, now let's talk about lateral area versus surface area. Lateral area is the sum of all the lateral side or face of a polyhedron. So basically, if I look at this prism right here, you have this side that's a rectangle, this side over here is a rectangle, and this side. So those three sides that are together would be the lateral area, would be how much paper would be needed to cover all the sides, okay? And then surface areas is the sum of the faces of polyhedrons, sides, and bases. So if you notice right here, we have the triangular base here, and that's uh, parallel to the top here. So when we do surface area, that means we're going to do all the sides plus the bottom plus the top. Okay, so um all the faces added together. In other words, if you were going to wrap this object, how much paper would you need it to cover all the sides? Now we're going to focus on prisms and cylinders in this lesson, and then we're going to talk about other polyhedrons later. But what is a prism? A prism is a solid with two parallel and congruent bases with rectangular faces, okay, or rectangular lateral faces. So if you notice right here, here we have a triangular prism because the bases are parallel and they are triangles and the sides are rectangles. This is called a rectangular prism because you have the sides and the base is a rectangle. Okay. Um, the cube is a special rectangular prism because a cube has a square as the base and all the sides are the same dimension. So all the sides are the square right there. Okay. Then we have the pentagonal prism, which basically you have a base that is a pentagon. Okay. And then hexagonal, a base of that is a hexagon. Okay, let's go on to the formulas. Okay, so we have two formulas that we need to know how to use. And the first one is L equals P times H, which L represents the lateral area. P represents the perimeter of the base, and H the height of the polyhedron. Then we have S, which is surface area, equals perimeter times height. And if you notice right there, that's pretty much the lateral area. Okay, so just know that once you find the lateral area, you already have part of your surface area. The only difference is surface areas, you have to add the two bases, okay? The two areas of the base. So this is a capital B, which stands for area of the base. All right, very good. Let's go on to the first examples here. So if you notice right here, we have a prism. The only thing is that that prism is laying on the side because you can see the base that is parallel is the triangle. So this is a triangular prism. We're going to start out by finding the lateral area, so which is perimeter times height. And when we try to find the perimeter, I have 4 plus 3 plus, I'm missing the third side, so let's call it x. And using Pythagorean theorem, a squared plus b squared equals c squared. We can plug it in the x as our hypotenuse, and then this would be 4 squared plus 3 squared. And then we just take the square root of both sides, and we get x equals, let's go to the calculator, second. So this would be 4 squared plus 3 squared, and we get 5. Very good. Now that we have that, we can put it over here, and the height of the prism is 10. So 4 plus 3 is 7. 7 plus 5 will be 12. 12 times 10 will be 120 meters squared. So there you go. We have our lateral area. Now let's find the surface area, which is pH plus 2 times the area of the base. Please notice that we already found this. So our job is almost done here because all we have to do is plug it in the 120. Now our base is a triangle, so let's plug it in the formula for a triangle, which is base times height divided by 2. Okay, now notice that I can cancel these two, making the formula a little bit simpler. So this would be 120 plus the base of the triangle is 4, the height is 3, and so this would be 4 times 3 is 12 plus 120, 132 meters square. So there you go. We have the lateral area and the surface area. Let's go on to the next problem. Next problem, I have a hexagonal prism is also laying on the side. Okay, so let's start out with the formulas. And the lateral area would be the perimeter. Now, we notice here all the sides are the same, so perimeter would be 6 times 4, and the height of the prism is 16. So put that in the calculator. 6 times 4 times 16. And we get 384. And this would be meters square. Very well. And just like before, we already have a head start on the surface area because we have this number, 384. Now we are going to plug it in the formula, which is for the area of the base, which is a hexagon, would be apothem times perimeter divided by 2. Again, here I can cancel the 2's. That makes my formula a little bit simpler. And the question is, do I have the apothem? And the answer is no, I don't. So that's something that we're going to have to find out. The perimeter, just like before, 6 times 4. So we have that. So all that we need to finish this problem is to find the apothem. Okay, so please remember, if we were to divide this into triangles, we will know that this angle right here is 360 divided by 6 angles, which is 60 degrees. If I draw the apothem there, and let me make a bigger picture so it's easier to see. So basically, this is my triangle here. And this here is 60. If I divide it in half, this would be 30. This would be my apothem. This side here is 4, but if I cut it in half, this would be 2. So there you go. I have 30 in front of it. I have 2, so that would be my opposite side. And this would be my adjacent side. So this would be tangent of 30 equals the opposite side 2 over the apothem. We're going to switch these places. So this would be 2 over the tangent of 30. Okay, let's go ahead and press mold. It's in degrees, so let's go ahead and clear that and press 2 divided by tangent of 30. And we get 3.4641. So now we can plug it in here, 3.4641, and then we can find the surface area. 3.4641 times 24, and we get a surface area of 467.1 meters squared. Please remember, if the problem doesn't specify, make sure to round it to the nearest tenth. Okay, and there we go. Here is the next set of problems, and this time we're going to talk about cylinders, which is very similar to prisms in the fact that it has two congruent bases, but the basis happens to be circles. Okay, So basically, a cylinder is two solids with two parallel and congruent circular bases. The formula is 2 pi r h, and the surface area is 2 pi r h plus 2 pi r squared. If you notice here, this is 2 times the area at the base. Okay, so very similar to the ones we did before, except now we're dealing with cylinders. So again, we start off with the formulas, and then we plug it in the information as we see it in the drawing. So 2 pi, the radius is 4, the height of the cylinder is 12. We go and plug it into the calculator. So 2 times second pi times 4 times 12, and we get 301.5929, which rounds to 301.6 centimeters square. Okay, now we're going to bring this value here, but don't round it to the nearest tenth. That's why I wrote it this way, because here it's not going to be a final answer. We're going to use this number to find the final surface area. So we're going to use it with 4 decimal places. So 29, okay, plus 2 pi, the radius is 4 again, square. So now we're plugging in that in the calculator. So 301.5929 plus 2 second pi times 4 square. Press enter, and we get 402.1 centimeters square. Perfect. Very well. Let's go on to the next problem. Next problem is very similar to the one before. The only difference is instead of the radius, we have the diameter. So, and knowing that the diameter is twice the radius, we know that the radius here would be 4 and 4. So again, what is the formula? For the lateral area is 2 pi RH, and the surface area is 2 pi RH plus 2 pi R squared. All we have to do now is plug it in. So 2 pi, the radius is 4, and the height is 20. Then we just plug it in the calculator. So 2 second pi times 4 times 20. And we get 502.6548, which we round to 502.7 centimeters square. Now I'm going to bring this value and plug it in here to find the surface area. So I'm going to use 502.6548 plus 2 pi times the radius, which is 4. And then we're going to plug it in the calculator. 502.6548 plus 2 second pi times 4 squared. And we get surface area to be 603.2 centimeters squared. And there we go. We found the lateral area and surface area of this cylinder. So this concludes the lesson for today. Today we talk about surface area and lateral areas of prisms and cylinders. I hope this lesson was helpful. Thank you very much for your time. Have a wonderful day. Bye-bye.